record on this computer, so we are recording now. Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. Peace upon all of you everywhere. You are welcome in my Grand Round Zoom meeting, Ziada Grand Round, which is conducting meetings about the cornea, cataract, and refractive surgeries. And today we have a special day because we have a special guest speaker. I like all the time to call him the excellence, the King Arthur. Really, I like to call you all the time the King Arthur, Dr. Arthur Cumming. It's very well known surgeon and researcher in the field of refractive surgery. I think he doesn't need any introduction, but he is a refractive and cataract surgeon, the director of the Wellington Eye Clinic, Dublin, Ireland, and he is one of the main corners in the all developments of the refractive surgery in the wave light related devices and techniques. And we are using to hear about the new innovation and the new good news about the refractive techniques and the solutions for the regular corneas solved by the customized ablation. And this is our topic today. Thank you, Dr. Arthur Cumming, for your participation and for your time. And it's really appreciable because I know that your schedule is so tough. Please, sir, I am asking you now to start your presentation about the customized ablation.
Thank you, Professor Ziada. It's very kind of you, and it's very nice to be with you.
It's my pleasure.
You can stop me live. I also know people asking questions. That's where you learn. Anytime I've said enough, you can stop anytime you like. So we're first going to speak a little bit about. I'm going to go with this one.
Yeah,
we're going to speak about.
You can share your screen
ray
now.
tracing because it. Yes, it should be showing.
Yeah, okay, nice now.
Contoura in the era of ray tracing. Okay, so these are my financial disclosures, and I consult for Wavelight and Alcon, which has something to do with Contoura and with custom ablations with the Wavelight platform. So what was new for Wavelight was that in 2015, topography-guided procedures were used for the first time for primary cases. In the past, we always used these cases or these technologies for retreatments or for old RKs or for corneal scars or previous PKP. But in the US, when they went for FDA approval, the FDA said they've got to go on new eyes. So in Barcelona in 2015, so it's almost 5 years ago, this was launched for the first time, topography-guided procedures for first-time laser vision corrections. And so it's called Contoura vision when it's used for the first time. So what the FDA study showed was that 98% of subjects indicated they would have the same procedure again. And then something else that they showed was that at 12 months, at the end of the study, that visual symptoms and objective visual acuity measurements had generally improved throughout the 12 months. And one of the reasons people think this happens is because with a topography-guided procedure, the laser knows what the corneal shape is like. It knows what the corneal current shape is. It knows what the corneal current Q value is. And so when it does a treatment, it blends the treatment zone in very, very well to the existing cornea that doesn't get treated. For that reason, you have very little long-term changes. It's very stable. And what the study showed was there was statistical significance for light sensitivity, difficulty driving at night, reading difficulty, and glare with TCAT LASIK. So that was in an FDA study. And any of you who have tried to emulate an FDA study would know we can't really get the same results so-called in a study. So what happens in the real world? So in the real world, there are three ways of thinking about Contoura. So topography guided. So the one is you can do it based on the manifest refraction, and then you should get results like the FDA study. Or you could do something called TMR, topography modified refraction. And this is something that John Kanellopoulos brought to the fore. And he was saying, well, you know what you should do? the most important refractive surface or interface in the optics of the eye would be the anterior corneal surface. So we should use that topography, cylinder axis, and magnitude, and then just make an adjustment for the sphere equivalent. And then there were many people doing some kind of a higher astigmatism where you blend between what can with astigmatism. But in this particular case, the refractive astigmatism is at 90 degrees, while the topographic astigmatism is slightly off. It's at 70 degrees or 65 degrees. And then normally a hybrid treatment would be somewhere in between, depending on all the other factors. So if you did a manifest refractive procedure, you would have a very excellent correlation between the manifest and the topographic cylinder and axis. And another guideline, if you're doing a topography-guided procedure and using manifest, is to look at the total higher order ablation profile and make sure that it's low. And then you're going to get very good results. So here's an example where here's the preoperative cornea. You then enter into the laser a 0 refraction, and then you see what the higher order ablation profile looks like. And on this profile, you can see, in fact, this thing's in the way. Now, you can see that the maximum ablation is 8 microns over the steep purple area and 3 microns in the middle. So because this is less than 10 microns, you can just do the manifest refraction and you should do well. And the only problem with this setup in the real world is that only 15 to 20% of people would actually qualify for Contoura if this was the only guide. So then if you do TMR, is use the topic is stable. I think I've seen more papers saying people are getting better results with Manning, but this assumes that there are other aspects or other properties of the optics that are impacting astigmatism. And so is vector analysis, there's the ray tracing technique. And then what I did mention there is there's also a technique called 4CDs, which is freely available now on the Wavelight platform. And
النت مش حلو خالص. اقفلوا النت عندكم.
With custom Q, we're getting even more. We're getting 0.99, which is almost exactly on target. And the reason would be is with optimized, we can only do 0.25 diopter increments, and with custom Q, we can do 0.01, so 1/100 of a diopter. Now, obviously, we can't measure that, but our nomograms, so many of us use nomogram tools like Ibro or SurgiVision consultants, and what they do is they say, instead of doing 3.5, they'd say do 3.61, and you can enter 3.61, and then you are very, very accurate. Now, when you do topography guided, which is in gray, it's the same thing. And why we're not quite as accurate there is because we're making adjustments for the higher order ablation profile, and obviously we still need to learn a bit there. So this is very interesting. If you look at the gray line over here, this is the line of stability over time. And you'll see of all these, the one that has the most stability is in fact Contoura. And that's something I said earlier, and that's because of this very good blend between the treated zone and the non-treated zone. And you know the epithelium, we'll talk a bit about the epithelium later. The epithelium reacts to sudden changes in curvature. So if you make those changes in curvature very subtle, then you don't see. So what's recently been launched, it's been, what's the word? It's been tripped up with COVID. So ray tracing LASIK is based on, I'll go through it now in a second, but it's based on a study done in 2009 in 3 centers, myself and Professor Seiler in Zurich and Matthias Maus in Cologne. And these ray tracing results showed the best results we've seen so far. And what ray tracing did was it, instead of using Gouldstrand's eye model, it created a virtual model and then did the calculations. So what happened now with the product taking 10 years to launch and on a different device, it had to go through some kind of a controlled launch to first of all see, is it working well? And this controlled launch started in January. And just at the time we were expecting to start seeing our outcomes and start following results, all our clinics shut down. So it's been a little bit of a problem. But anyway, the original study was done higher than -4 sphere equivalent, or those with astigmatism of more than 2. And so this is why I wanted to speak about this, is irrespective of what customization you use. So wavefront optimized, you all understand, is basically a standard treatment, except it's compensating for spherical aberration. Wavefront guided, you're measuring the wavefront and then treating the wavefront. Topography guided, you're getting all of the aberrations from the corneal surface and then treating the cornea. And then custom Q is where you have the ability to fine tune the asphericity of the cornea. But irrespective of how sophisticated these diagnostics may be, when you treat the eye, the laser thinks you're treating Gouldstrand's model. It thinks you're treating this eye. And the standard eye has a length of 24 millimeters and has a corneal curvature of 43 diopters. So what's absolutely amazing is Gouldstrand won the Nobel Prize, and he's the only ophthalmologist ever to win the Nobel Prize. And his model is more than 100 years old. It was 1911, so it's 109 years old now. So his model on the eye was around 60 years before laser was anything. Before laser, it was microwave, amplified simulation of emission of radiation, became laser in the 60s. So laser had its 50th anniversary about 5 or 6 years ago. So his model outdates laser by twice the time. Yet to this day, every single treatment we do is still based on Gouldstrand's model, unless you're doing a ray tracing profile. And so with the ray tracing, what made it possible back 10 years ago was when this device came. And this device is the LensStar, but it was licensed to Wavelight and called the Wavelight OB820. And the difference with this is its wavelength was at 820, where the IOL master is at 780. And the difference is at 820, you can see the lens. So yeah, you can see the anterior lens surface and the posterior lens surface, where with the IOL master at 780, you couldn't see the lens. And the moment you could see the lens, you could now start modeling the eye. So this is what happened, is instead of using a basic refraction with ray tracing profiles, you actually use the wavefront. So you use the wavefront as your input, and then instead of using Gouldstrand's 43 diopters that is standard, you now use a pentacam that has 24,000 points. You also get information from the pentacam on the back surface of the cornea and some information on the front surface of the lens. But when you add the biometry, now on the central axis, you get everything. You get back surface of lens and you get the retina. So now with that information, wavefront, biometry, and corneal data, you can create a virtual model. So with those 3 things, you can create the lens now. So we don't have measurements for the lens, except the front surface, but you can now recreate the lens, and now you have the model. And once you have the eye model, you can plan your treatments on the eye model. So if you look at our previously best treatments with wavefront guided, so we had a wavefront measurement, but we had no corneal information, we had no biometry, and some values were taken from the literature. And wavefront overall gave us very good results, but sometimes didn't make sense. When you're doing ray tracing, you have all of those measurements. And so the potential is there to get a much, much higher result. Now, here's another thing that ray tracing does, which is very interesting, is it includes the expected biomechanical response. So if you're doing a LASIK and you're doing a -1, it might have a different biomechanical response to a LASIK at -8. So it would anticipate that. And the other thing it does is, depending on the amount of flattening you're getting, it also knows what sort of epithelial remodeling you're going to get with thickening centrally, and it can propose for that. And then you could also do this without wavefront data. So you could do it with a normal refraction, because what happened was you would get the refraction, you would send the information into the algorithm. The algorithm would then, on the virtual eye, would do a treatment with what it thought was the best treatment. If that treatment was perfect, when it now allowed rays through the eye, they would all focus perfectly on the retina. But obviously they never did. So here's where the ray tracing came in. People then ray traced the ray backwards from the fovea onto the cornea and said, how must I change the cornea to make this ray arrive in the right place? And that's where it comes from. So this was 10 years ago. The outcomes are phenomenal. 3 centers. When you look at these are the FDA results. And we have never been able to previously compete with the FDA. So when you look at the FDA results, they're spectacular. But when we broke them down to between -4 and -7, or more than -7, with wavefront optimized, which were the best results ever to be seen in 2003, 80.8% between -4 and -7 we're getting 2020. And over -7, only 70.6. Ray tracing was getting 93.7 and 90 over -7. The wavefront guided was also very good. It was a big improvement over wavefront optimized, but they weren't doing over -7. So this was the first time ever we were showing results better than what the FDA was showing. So what I did once we had 1 year data is I went and looked at my own data in the clinic, and I did this retrospectively, and I looked at all the same ranges. So more than -4 or more than 2 diopters of astigmatism. And when I looked at wavefront optimized, and this would be a profile for any good laser. So all of the modern lasers will get the same profile. You'd have maybe 6% of patients losing 1 line of best corrected acuity, and you'd have between 15 and 17% of patients gaining a line with an aberration-free profile. If you do wavefront guided, you move that column slightly to the right, where more patients now are gaining lines and fewer are losing lines. With custom Q, it looks very much like wavefront guided. It's a very, very nice profile. Now, what I've got to admit here with Topography-guided, this was way back in 2005, 2010, that kind of data, where we were doing complicated eyes. And this isn't Contoura, which are untreated eyes. So with Contoura, the results are very good too. But look at ray tracing. On my own data, we had no one lose a line, and we had 75% of patients gaining 1 or more lines. So that was something we'd not seen before. And the only difference between these 5 treatments, the same surgeon, same laser, the laser was a 400 IQ, not the EX500, was a keratome. The only difference was the ablation profile. So ray tracing really looked very promising way back. So why it was deemed to be necessary to do a controlled launch was, first of all, we knew from the study that ray tracing really helped a lot when the cornea was different to 43 diopters, or the axial length was longer than 24. So the more the eye was different from the Goldstrand model, the better it did, because you were taking care of those outliers. So the question going to market now is, how will ray tracing fare in the clinic doing all comers? So this launch started earlier this year, and at 1 month overall, ray tracing was actually doing Innovize was doing better than ray tracing from 10 years ago. But we don't have a lot of follow-up. So at this point, I don't want to say more. It looks very promising, but we need to study first. And why it needs to be studied is 2 things. One is the previous devices were 3 separate devices. Now it's 1 device. So of course, you've got to see how is it behaving. And then the second thing is the original wavefront analyzer was a churning system. And on the Innovize device, the sitemap, it is a Hartmann shack. So when you make changes like that, you've got to first validate to make sure the data is good. But there are 5 centers that are using it. And so far, the overall consensus is it's very good. So the software shows us things like this. On the screen, once the data is captured, this is on the laser now. You can see the wavefront, you can see the topography, and you can see the biometry. And when you go into the wavefront specifically, they want at least 4 maps, and these are the higher order aberrations. And you can see on these 4, they look very, very similar, so accept all 4. Now you're going to look at the topography, and on the topography, which is coming from the Scheimpflug, again, they're very, very similar. If you look at all the metrics, they're similar, so again, we'll accept them. And this is the anterior surface. You can also look at the posterior surface, and then you look at the biometry, and it looks at the signal to noise ratio and make sure that these are good biometries. And once you know they're pretty good, now it takes less than 60 seconds to generate the profile. So when we started, all of us who do customized treatments always want to know, what does the higher order ablation profile look like? Does it look like this is going to solve the problem the patient has? So at the moment, we're only doing these innovative procedures for patients who are new. We don't want to complicate matters, but I've been using it diagnostically on all kinds of eyes. There's a patient who had wavefront optimized LASIK just a couple of years ago for -775. His best corrected acuity was 20/20. And in fact, he landed up seeing 1.3, so better than what he was before, but he wasn't comfortable. He was really uncomfortable at night. So I wanted to see how we could fix this. So if we were doing his refraction, which was +50 -1/4, this would be a wavefront optimized profile. But if we were doing an oculink, so using the Scheim fluke to decide the treatment, you could see it's different because it's now using it's treating spherical aberration and some coma. If you now go and do Contoura using the Placido disc, it looks pretty similar. So you can imagine when we did Innovise off the sitemap with ray tracing, the fact that it looks similar was very, very reassuring to us. At least it's addressing the same sort of higher order aberrations. So it gave us a lot of confidence that it's measuring the correct thing. What's interesting with Innovise, it includes tilt, which none of our other profiles do. So when you actually do the treatment, it looks a bit better. It looks a bit different. It looks like this. So the software allows you to go and hit this button just on higher order aberrations, and then you see what the higher order aberrations look like. But it's just a simulation. It's very interesting. It's quite difficult to get your head around, but with our other profiles, you've got the basics, pure optics, and then you've got the aberrations over and above that. With ray tracing, you're not really specifically measuring the aberrations. You're doing this reiteration process, and you keep on changing the shape of the cornea until the rays coming in focus on the macula. So it's slightly different, but it allows us to look at what the aberrations look like. So the question is there still a place for Contoura vision when you have ray tracing? And let's see what this looks like. So Contoura 1 has manifest refraction. And if you look at what this looks like, the results are very, very good. But the FDA was still outperforming anything else we'd seen. And then the training protocol, when you went through the training protocol, you stuck to it like you should do when you're starting something new, is we found that there's a very small percentage of patients who actually qualify for it. 10% of patients in the US are qualifying for Contoura on the FDA criteria. Then on TMR, the topography modified refraction, now when you did this, you started seeing that you were competing. You were starting to compete with what others looked like, what the FDA looked like, but FDA was still outperforming, and FDA was manifest. And then when you go to Forcides, which is this method where you measure the higher order aberrations on the cornea. So it comes from geoimaging, and these people look at the contours of the earth and they can contour it. And Mark Lobanoff, who's the person who invented this, he went to 5 companies, all said to him, no, we work in meters and thousands of meters where you're talking about microns, we can't help you. But the 6th company that he spoke to said, it's the same thing, it's just relative scale. So they helped him. And what they helped him do is figure out that when you look at the higher order ablation profile, the shape of that profile is going to change your prescription when you put it on the cornea. And they did these calculations for him. And they call these areas of more prominence, they call it talus. And they can calculate the weight of a talus. So when you look at the results that Mark Lobanoff got with a group of 4 other investigators in the US, they now completely outperformed the FDA study. So now they're getting much, much better results. I mean, they're getting more than 50% of patients are 2016 or better. So really getting spectacular results. And outperforming the FDA study, which had this very strict criteria to enter. So, and many more eyes were gaining best corrected acuity, 42%. So this is how you do it. You import the higher order ablation profile, you enter the refraction, you enter what the device is telling you to treat for a Contoura, you enter that, you enter additional data off a pentacam, you enter the posterior curvature, and it then does the calculation for you and tells you exactly what to do. It automatically picks up the taluses. If you want to, you can go and add lines to pick up something that the software might have missed, but it does this amazing calculation and now tells you this is what you should treat. So if you look at the screen, I don't know if you can see it, but Contoura was saying do minus 0.27, minus 155 astigmatism. The manifest was saying do 225. But once this was placed through Forcides said, no, there's internal optics astigmatism, only do minus 0.92. And Forcides turned out to give a very, very good result. So Contoura is not going away. There's no chance it's going away, especially when you really use Forcides to do the calculations. It's a very, very good tool for quality of vision. Innovise requires further hardware. You've got to buy a device called the Sitemap, which is the 3-in-1 wavefront Scheimpflug biometer. And 80% of eyes we can measure for Innovise, the 20% we can't. And those eyes where you can't measure because it does a wavefront without dilation. And sometimes you just can't get the pupil wide enough. So Contoura definitely won't go away. And I think what we'll find is ray tracing will be fantastic for. It's a very nice solution for one device to do the measurements. And so that's all you're doing on the up front, but on the back side, you're doing the most customized procedure possible. But Contoura simply won't go away. It's tried and tested, it's working very well. So Hassan, would you like me to stop there and we have a bit of a chat, or must I speak a little bit about keratoconus and surface treatments for keratoconus? Maybe do that.
Yes, Arthur, thank you for this presentation, but it's very important to run over the keratoconic eyes regular. It's very important topic.
Perfect.
Please. Yeah.
All right, here we go.
Okay.
All right, so here's the interesting thing is if you want to speak today about doing customized treatments, topography-guided for the cornea, and keratoconus is a prime example of this. You have to do this with epithelial maps. If you don't have epithelial maps, you're going to get very, very big surprises. And I'm going to try and show you why that's the case. So epithelial mapping currently is used for keratoconus detection. It gets thinner over the cone. It explains many times why you get a funny refractive outcome and you can't understand why. And you can look at the epithelium, it tells you exactly why. And also it can help you detect dry eye. So how can we harness that power? And we're just going to show you some ways that the epithelium can be used to your benefit. So mostly the epithelium is 5 to 7 cell layers thick and is about 51 to 54 microns, almost always. And we all know the functions of the epithelium. And normally the map would look like this, very, very uniform. And this is a classic example of what the epithelium looks like in someone who had previous myopic LASIK. It could be 1 year ago, it could be 10 years ago, it could be 20 years ago. At some point, you get epithelial remodeling and the epithelium gets thicker over the central ablated cornea. So what you do with a transepithelial PRK is you remove the epithelium with the PTK, and that would depend on what the thickness of the epithelium is. And you choose the epithelium thickness where the epithelium is thickest. And so this is how it would work. So here's a patient with keratoconus. You can see on this inside line, there's the bump. You can see on the anterior line that there's also a bump, but the bump is less severe than the true stronal surface because the epithelium is masking it. So the epithelium is much thinner over here and thicker at the sides. So now if you do a trans-epi-PRK, the transepithelial part, the PTK part, is like a contact lens with no power. It's the same thickness everywhere. So as you start going down into the cornea, right at this point here, you started going into stroma, but at this point you're still in epithelium. As you go down, you've now taken quite a bit of stroma away, but yeah, you're still in epithelium. And then finally you go all the way through, and then you go and look at what you achieved, and you suddenly find that the stromal removal is not looking like a PTK, but in fact is very, very customized. And you've just gone and treated the exact error that the epithelium was masking. So it's a very, very powerful tool. So you can often treat keratoconics with nothing more than just a PTK at the depth of the thickest epithelium. So you remove all the epithelium in the optical zone, and in some parts where the epithelium was thinner, you take stroma away and you get incredible regularization of the surface. So that's what your PTK did for you. And when you do a topography-guided procedure for keratoconus, you always find that there's an ablation area over the cone, and that's going to flatten this area. And if you look at these examples here, look at every single one of them. There's treatment over the cone, and then there's an area over here which is very peripheral. It looks like part of a hyperopic treatment. What any hyperopic treatment does is it steepens the central part. So what this is going to do, it's going to steepen this area. So doing a treatment like this, topography guided, you flatten the cone and you steepen this area. So what happens is you go from flattening the cone, steepening this area, and you get much more regularization. And then on top of that, you have the effect of the epithelium. So if you do a combined topography-guided transepithelial PRK, you can expect incredible regularization from the cornea. I want to show you how powerful the epithelium is. There's a 58-year-old patient, previous LASIK, and had 2 previous topography-guided PRKs for glare and halos. And 59 micron PTK, you know something. I'm actually going to skip this case and show you another one. I don't want to take too much time with this.
Okay.
You know what I did? Unfortunately, awesome, I put the wrong. I want to show you this one.
Yeah.
So it really shows you the power of the epithelium.
Yes.
So here's a patient of 54, had LASIK in 2007 for, I think, -7, had a PRK enhancement a couple of years ago, 3 years ago now, and just for one eye, for the left eye, that was measuring -150, -1. The truth is, both eyes had regressed to around about -150, and with the patient being presbyopic, we said, hey, we know what we'll do, we'll just treat the one eye and you'll have a blended vision. So we had just started using epithelial mapping, and so this is the right eye, the one we didn't treat, and we saw the epithelium was 67, took another map, it was 67 again, so we started seeing, you know, these devices have repeatability, and then on the left eye, epithelium was 63, 64, so again, within a micron. So we treated the patient with a PRK. Day 1 was 20/25, week 1 was 20/30. It's sort of what we see normally. Month 1, the vision was 6/30, which is terrible. It's 0.2, +1, +2 to 5. It's like, what's happening over here? And correcting really a loss of BCVA. So because we had this machine now, we repeated the epithelial map, and suddenly our 63 microns had gone to 52, okay? So now we started following the patient. At month 3, 615, BCVA is improving luckily. Month 4, 620, +150. Month 6, +150. So I'm saying to the patient at this point, my experience is that you don't normally change after month 6. So I think what we should do is we should go and do an adjustment for you. And she said, no, I think it's getting better. I don't want to wait a little while. So we waited another couple of months, and she finally corrected to 20/20, and with +1, +0.75. Now look at the epithelial maps at the same time. Month 2 was 51, month 3 was 53, 54, 50, 60, and 63. So it took 8 months to get back to 63. But now you may recall now that the preoperative map was 63. And this one's 63, so why are we still +1? And the reason is the shape of the epithelium. And the shape of the epithelium currently, I can go back, I think, yes, exactly, has this flattened area centrally where it's 63, but around the periphery it's 70 and 68. And if you had slightly less, it's 62 and 61. So the epithelium, you need to think of it almost as a contact lens. It has a huge amount of impact on the vision. And we have 2 different devices, and one of our devices, I don't consult for them. They're a company called CSO, and they have a device called the MS39. And their epithelial maps actually have the ability to give you a predictive refractive power of the epithelium, and that's very handy when you're doing these cases. So I think all I'd say further there, I don't think there's anything more I want to do over here. It's just the way we are currently doing combined treatments. So we started doing cross-linking in 2007, and just maybe 1 year later, a patient said to me, "Doctor, do I still have keratoconus?" And I said, "Yeah, of course you do." He said, "Well, hang on a second. Every time I see you, my cornea is getting flatter." So I said, "Yes, that's from the cross-linking." And he said, "Well, the cross-linking was for progression of the steepness." And I said, "Yeah, that's true." So he said, "Well, do I still have keratoconus if I'm getting flatter?" I said, "Yeah, I must tell you, I don't know. It's a good question." So he said to me, "Would it be possible to laser? Because I've got a stronger cornea now. I've got a thick enough cornea. Would it be possible with laser to do something?" And at that stage, John Canalopoulos had started doing that. So we started doing a procedure at the same time. We call it SIMLC, simultaneous laser cross-linking. So we would do a topography-guided procedure and directly at the same sitting do a cross-linking. It worked very, very nicely. It was very unpredictable. You could get serious flattening afterwards. And the other thing is we had quite a couple of patients who had a very delayed healing, a long healing, because we were doing the 2 procedures in one day. And then people started doing the cross-linking first, and then 6 months later doing some PRK. I didn't do many cases like that. I did a couple, but I didn't do many. I didn't like the idea of strengthening the cornea and then lasering that same tissue away. So what we started doing a few years ago, maybe 4 years ago now, is something I learned from David Lin. David Lin has done something like 60,000 PRKs, and many of the PRKs he has done were for keratoconics. He had like 1,200 keratoconics that he had done at topography-guided PRK, and with follow-up to see if they need cross-linking. And of those 1,200, none needed cross-linking. So the moment he did a topography-guided PRK, he sort of got a redistribution of the stresses within the cornea. And so we decided with patients to say, right, what we'll first do, as long as you have enough tissue, we'll do a topography-guided PRK, and then we'll monitor you. And at any point that we see your cornea is not maintaining its shape, we will then do cross-linking as an Epi-on. So that's how we do it now. And we're doing it for the last 4 years. And once in the last 4 years, we've gone and done the cross-linking. So every other time, even for a keratoconic or a form fruste, we've done the topo-guided PRK, and it didn't progress the keratoconus. Now, in fairness, I'd only ever try and correct the refractive error, if it's very, very small and using combined less than 50 microns. And if it's more than 50, I just tell the patient, look, we're going to make your cornea more regular. You can use contact lenses or glasses afterwards, or an ICL, but I don't want to take too much tissue away. But David in Vancouver, David Lin, was doing the refractive error at the same time and still finding stability. So it's a very interesting concept, Hossam.
Yeah.
That for patients, if you do a LASIK, of course, you know you're going to go in the wrong direction. The PRK, especially topo-guided, it seems like you get this redistribution of forces. And of course, patients stop rubbing. That's the key part. You've got to tell them they've got to stop rubbing.
Yeah.
Give them an alternative, and we call it finger to bone. So rub the inside corner of your eye, your forehead, your cheekbone, but don't rub the eye.
Yeah, the mechanical stiffening of the cornea, mechanical ectasia.
Exactly.
Yeah, okay. Thank you, Arthur. Yeah, wonderful presentation as usual. And a very rich presentation, a very guiding one, King Arthur. And as you know, that many of the refractive surgeons everywhere are following your recommendations about the Contoura and the other solutions for the customized ablation. But you actually finished your presentation with a very important question. I would ask you about it, which is the topography-guided ablation for the very early keratoconus or form of frost one, combined or not to be combined with the cross-linking. And you said that you are not with to be combined at the same session. Right?
Yes, so we combined it for many years, from 2007 to maybe 2014, somewhere there. For 7 years we did it. But we got very good results. The problem, there were two problems. The one was you had no idea when the flattening would stop. So when you did a combined procedure, you got a very, very strong cross-link. Number one, the PRK had removed Bowman's membrane. Of course, the epithelium's gone. And so the soak was very, very strong, and the cornea is thinner, and so you get a very strong. I had one patient who was -7, his sphere equivalent, and I saw him at 5 years later. He was so happy. He was absolutely over the moon. I did not do the refraction. I just did a 0 power, topography-guided PRK, and then the crosslink. 5 years later, he was -1. He was over the moon, and I was getting very nervous because I'd seen this change from -7 to -1. 1 year later, he was basically emmetropic. And now he was even happier, and I was becoming nervous. 1 year later, he was +1.5, and a year later, he was +3. So you have no idea of how much flattening, are you going to get flattening, number one? And if you do, how much will you get when you do the combination procedure? So what we do nowadays is we do the topo-guided PRK, trans-epi, topo-guided PRK. So if you do a trans-epi topo-guided, you're getting the ultimate regularization of the cornea. You can't do it in one go. You can't do it better than that. But then you wait. You wait for 6 weeks or 3 months or 6 months. What we're doing currently is we're waiting indefinitely. We're waiting to see if there's signs of further ectasia, and only then will we cross-link. And then when we do the cross-linking, we're doing the cross-linking Epi-on. We've been doing this since 2014 for the last 6 years. And with our Epi-on cross-link, we've had one failure in 6 years, one. And the very nice thing about that is it's super safe. We've had not a single problem with Epi-on. And then the other thing is you don't get funny surprises. You don't get crazy flattening. So you tend to get stability, nothing more. And so that's worked out well for us. It's a much more gentle approach. I think most places have sort of, if I read between the lines, most places have gone away from the simultaneous treatment.
Yeah, okay.
What's your impression?
Actually, I had a case the last week for simultaneous treatment, but it's not chronic one, but actually he was a patient with very regular corneal surface, which is related to the epithelium, and the subepithelial fibrosis may be related to the trachoma, the pannus, and the other multiple superficial traumas to the cornea. But actually, I couldn't diagnose this patient as a keratoconic one, but very regular cornea with thin cornea, the low normal thickness. So I like to be in the safety margin. This patient has very high order aberrations. He is not comfortable with his glasses, and he's a driver. So he was seeking for a correction for this high order aberration. So I introduced, I thought about the topography guided more than the wavefront in such case, because actually we don't have here the wave light Contoura or the ray tracing. I think it's not available everywhere up till now. But the question here, we have to wait for 6 months after the PRK because of the epithelial remodeling, or for another cause?
Is this just for the cross-linking?
Yeah, okay. If I did a PRK, topography-guided PRK for a patient, and I was planning for the cross-linking, I have to wait for 6 months, or I can do it earlier?
You can do it after 1 week. As soon as the epithelium is healed, you can do it after 1 month, 3 months, 6 months, 6 years. So what we're doing currently, there are times when the condition is progressive, so we know we have to cross-link. And then we would typically do the treatment today and the cross-linking 1 week later. 1 week later, as soon as the epithelium is healed, we do a trans-epithelial cross-linking. That epithelium survives it very, very well. You could even wait a second week if you're nervous. Today, we're waiting longer because most of the patients we're treating with topo-guided PRK are not progressing. Their cornea is remaining very stable. So we monitor them, and only if they show signs of progression will we then go and do a cross-link. But if you know up front, this patient is progressing, and I'm definitely going to do the cross-linking, you can plan it from as soon as 1 week or 2 weeks after. Are you doing cross-linking epi-off?
Yeah.
Okay, so then the only thing you've got to think about is your PRK would have been quite an inflammatory procedure with taking, the eczema laser, taking off the epithelium.
Yes.
And then a week later, you've just about healed and you take the epithelium off again. That'll be another insult. So I'm only speaking about doing it this way if you're doing an epi-on cross-link. So an epi-on cross-link, the epithelium remains in place and you're not taking it again.
This is the point which I want to raise. The epi-on and the epi-off. I may wait for 6 months for the follow-up itself, to follow this patient up. If there's progression or deterioration of the cornea, I will go for cross-link. If not, I will complete the follow-up. But actually, if you have a case of Keratoconus and you underwent topography-guided PRK, and actually it's diagnosed as an early Keratoconus, grade 1 Keratoconus, and you you plan to regularize the surface, you will do cross-linking, or you will follow up to decide. It's actually, this patient is actually Keratoconic one. You will wait for the deterioration, or you will do it for the stabilization of the cornea.
No, I would do this with your second option. I would follow up to decide. I would follow up to decide, because the massive majority of these patients do not need it. So we never do a cross-linking or a PRK or any procedure, to tell you the truth, until we have completely explained to the patient that they may not rub their eyes. So what we tell patients is, there's a crazy thing in Ireland. People have insurance and they cover most of the medical things, but they don't cover cross-linking, which is like crazy. So people pay for cross-linking out of their pocket.
Yeah.
So I tell them, if you are still an eye rubber and we decide to cross-link you now, you are wasting your time, you're wasting your money, and you're wasting my time, because we're going to strengthen your cornea for sure by 100, 200, 300, 400% maybe. But if you start rubbing like this, you're going to break the bonds we've just recreated. So you've got to stop the habit first. And once you've broken the habit, then we can think about cross-linking you. So these guys, once they've had their topo-guided PRK, they're not rubbing anymore. After a PRK, your eyes are a bit tender anyway, so you tend not to rub. They break that habit. You've got to give them an alternative. This finger to bone works very well. If you rub this inside canthus, it gives you the same kind of relief as you get from rubbing your cornea, but you're not hurting anything.
Yes.
And
Okay.
I'll tell you a crazy thing.
Go ahead.
I'll tell you a crazy thing is what we see with patients, and this is even patients in their late teens, early 20s, who are coming with keratoconus. And if we know they're still rubbing, I'll tell them, and their parents are always with them. I'll say, right, for two reasons, we're doing nothing right now. Number one, if we treat you, you're wasting your time and money because you're going to break the cross-links. But the second thing is, if you stop rubbing now, there's a chance that when I see you in 3 months or 6 months, your keratoconus will be better because you've stopped rubbing. And Hassam, take a guess, what percentage of patients, young progressive keratoconics, when they stop rubbing, 6 months later look better? Take a wild guess.
I guess that around 60% of these patients will be stable if there's no rubbing.
That's a super guess. We find 50%, 6 months later are better. So we don't cross-link them. Let's say, hang on a second, cross-linking is for progression of the corneal steepness. Since you stopped rubbing, your cornea has come back. It's flattening slightly. You don't need anything. So that's how we make our decision on, are we going to cross-link a week or two later? So if someone's been progressing, they've stopped rubbing. So we do see people who've stopped rubbing, obviously, and they're still progressing. So if you do a PRK for them, they're going to progress. So once we've done the PRK, we'd normally wait 6 weeks just to get them comfortable and seeing quite well, and then cross-link. But you could cross-link. Sometimes if people come from abroad, we cross-link them 1 week later. And with Epi-on, you can cross-link both eyes same day. I don't know if you do that in Egypt. If you do both eyes same day, Epi-off, that could be quite sore and maybe a bit of a risk. Epi-on.
We have a problem here with Epi-on because 2 or 3 studies have been conducted for the comparing Epi-on and the Epi-off, depending on the corneal biomechanical changes after cross-linking. So this was the next the next question for you. I know that you recommend the Epi-on, and you are satisfied with it. How to decide, how to evaluate your cases, and can you guess why these studies conducted here didn't recommend the Epi-on?
Yeah, I can guess very well, because it's not only studies in Egypt, it's studies across the world have generally shown Epi-on does not work. And there were a few very important reasons why. The first one was they used the very same protocol that you would use for Epi-off, they used for Epi-on. So the first problem is, if you put dextran with the riboflavin, it can't pass through the epithelium. So you were getting no riboflavin in the cornea, in the stroma. You weren't getting. The second thing, which I found amazing, is people were not, before they did the illumination, they were not going to the slit lamp to check, is this cornea full of riboflavin? They weren't checking it. They were just assuming after half an hour it's full, but it's not. You've got to check. And then the third thing is during the treatment, they were putting drops on the surface which is what you do for an epi-off. Of course, you've got to do for an epi-off. The epi-off has no protection. It's dehydrating. So to keep it smooth, you put on riboflavin drops. Epi-on is completely different. You don't use dextran. You use a stronger concentration. You first prepare the epithelium by very gently removing the phospholipid layer. But there's a very special little brush we have. So it depends on the protocol.
Yeah.
But anyway, you remove this. You put a high concentration. It goes through very, very well. In 25 minutes, we get a very good soak. Of course, you monitor and you validate that on the slit lamp. If there's not enough riboflavin in the slit lamp, you put some more on. And then, before you put the light on, you know what you do? You take 1 minute with BSS to wash the riboflavin out of the epithelium. You don't want to cross-link the epithelium. You want to cross-link the stroma. And you don't want the riboflavin in the epithelium blocking the UV. So you've got to wash out with BSS for 1 minute. It washes it out. So on the slit lamp, the epithelium is white and the stroma is green. Now you're set up for a very, very good cross-link. And then during the treatment, the only drop you put in the cornea is a lubricant drop. You don't want to put ribo in the cornea. It's going to soak the epithelium and block the light. So you want the only place that the reaction is going to occur is inside the stroma where the light and the ribo are reacting. And then what we've been doing for 6 years is a very primitive way of doing, what do you call it again, when you intermittently pulse, when you pulse the light. So what we do, one of our PhDs did a study which showed that within 1 minute, you'd sort of use all the oxygen. And within 10 seconds, you could get quite a lot of oxygen back. So every 1 minute, the last 10 seconds, we just block the light out. That allows new oxygen to flow in. As I say, we offer an epi-off treatment at no cost if epi-on fails. So I wouldn't be doing it if I was retreating every case with an epi-off. It's been working amazingly. Yeah, so it's a very nice system. It's called CXLO. Again, I don't consult for them. It's a very nice system out of the US. Works very nice.
Yeah, okay, I know that by these points you have mentioned, it's actually a different protocol should give different results. We may think in a project about that, and I will be honored to share with you this work.
Fantastic.
Okay, thank you. And actually, the important point here, if we are going to do the cross-linking later with Epi-on technique, we have to wait. But the point which pushed us, or the surgeons who are doing that, the simultaneous technique is double insulting, the double removal of the epithelium. And most of the surgeons or the researchers who are refusing the simultaneous techniques, actually they didn't talk about these points that you have mentioned. They were talking about the double insulting, the exposure of the eye, of the Bowman's membrane or the stroma to the laser first and then to the UV light. I don't think in that. Really, I don't believe that it's double insulting, because during the last 10 years, I have done a lot of combined cases with no complication, actually with no epithelial defect or delayed healing if I addressed the post-operative treatment properly and follow up properly with this patient. But I am convinced by your way, if I will wait for the cross-linking with Epi-on technique with the different parameters you have mentioned, I will agree, and I will recommend that like you. So I will back again to the first presentation about the customized ablation. Can you give the secrets of the Contoura in 2 words, please? Because it was very fast. The Contoura and the topography-guided. In just 2 words, what's the difference between the Contoura and the topography-guided ablation? If I have a patient with regular cornea, high-order operation, which is translated in the patient's complaints in the form of halo surround light, the very difficult night driving, and some other signs who are which is well known for all of us. I can address this patient for the Contoura treatment even without error.
Yeah, so Hassam, it's confusing. Unfortunately, it's a marketing term. Contoura is nothing more than a marketing term. So Contoura is topography guided, but it's topography guided with some certain conditions.
Yeah.
It's myopia, myopic astigmatism,
Yes,
LASIK, first-time procedure. That's it. So if you do a topo-guided procedure for a hyperope, it's not Contoura. If you do a topo-guided PRK, it's not Contoura. If you do a topo-guided PRK with the oculizer, the pentacam, it's not Contoura. So Contoura is just a very small segment of topo-guided, but specifically first-time procedures. So historically, when we first got topo-guided in 2004, it was only for complicated eyes. It was for eyes where we couldn't do a wavefront.
yeah.
And so it's always been a repair tool. So they had to make a new name that people knew. Topo-guided is no longer only for repair work. It's actually there for primary cases. So Contoura, if you do a previous RK or a previous small optical zone size that you are enlarging, even if you use the Contoura software, it should be called a topo-guided. So it's just a technical term. In your mind, Contoura and topo-guided are basically the same thing.
Yeah, okay, perfect. Arthur, I ask this question because most of us are confused about the two terms. So I like to be clarified. The next question will be about the same question. High order aberration treatment is for topography guided or for the wavefront guided, which is better in your opinion? Away from the ray tracing, it's not available. If I have a patient with significant high order aberrations, which is recorded or reported by the wavefront scanning, I think the pentacam cannot guide us about that. There's no real points to define the high order.
The pentacam can guide you like Placido did on corneal higher order aberrations, but you need a wavefront analyzer to give you the ocular wavefront.
Yeah.
So what we would normally do is, for a primary eye, if there's some irregularity in the cornea and in the wavefront, if you get a good wavefront map, you can do wavefront without a doubt. You'll get a good result. But there's a very good rule of thumb to bear in mind, and that's this. Think about this. Think about having a perfect cornea, okay? But you have intraocular aberrations. So your wavefront tells you you have aberrations.
Yes.
Now you're going to do the treatment, and guess what your cornea does? Your cornea becomes less regular to correct the irregularities in the eye. And it's never a good idea to make the cornea more irregular. So one advantage that topography guided always has over wavefront is topography always aims to make the cornea more regular. So that's a positive. The challenge with topography guided is it's only correcting the cornea, and the rest of it, how do I treat this refraction, is up to you. You've got to make that decision. And that's where ray tracing helps a lot. And that's where 4 cities helps if you're doing Contoura. The beauty of wavefront is you don't have to think about it, because the wavefront is part of the treatment. It's already measured the refraction on a wavefront. So they have their pros and cons. I think if you're doing a procedure and you compare them, you have a wavefront, you have a topography guided, and the ablation profiles look similar, I would do it wavefront guided, because then you know I'm not making the cornea more regular, because it looks like the topo guided, but in the wavefront, I've got the higher order aberrations of the optical system.
Yes.
So I would go wavefront guided. But most times, especially on retreatments, the problem is in the cornea. If someone's had an RK or a decentered corneal treatment, the problem is in the cornea. So then it makes more sense to use corneal information to correct it.
Okay, Arthur, thank you. But give me clues about that. When to consider that this patient may be with high order aberrations related to the cornea. If there's a high corneal astigmatism?
No, not necessarily. You can have high corneal astigmatism with no aberrations.
Yeah.
So you can look at your Placido disc device or your Scheimpflug device, and you can go and look at the higher order aberrations. Some of them would show you the corneal higher order aberrations. What I really like on the corneal devices is I like the Fourier analysis. The Fourier analysis is beautiful. It shows you what the spherical component is. It shows you what the regular astigmatic component is. It shows you the coma component or decentration component. And then it shows you the last slide is just called irregularities. And it's often a trefoil or a quatrefoil. So it shows you very, very nicely what the aberrations are. And it also gives you a scale where it highlights those that are problematic. So if I'm doing a multifocal IOL for a previously lasered cornea, I'd always go and look at what those aberrations look like. And if they're low enough, I know I'm fine with a multifocal. And if they're not low enough, it's better to go with the monofocal.
Okay, so the Pentacam will help me to find that.
Yes.
Actually, I have read that the Pentacam HR is using now the ray tracing model to find
in the cornea, only in the cornea.
Just in the cornea, not in the posterior part of the eye, not into
only
the
ray
anterior.
tracing the cornea. Yeah. With the ray tracing is using the entire optics of the eye.
Yeah. Okay. Actually, I have a projects now we are working on about the corneal, the epithelial mapping and its role in the masking effect, about the masking effect, and about the unpredictability of the postoperative results. And we are using the MS39, which is a fantastic device, really.
Beautiful machine.
Yeah. Okay. We are working on the cutoff points about the accuracy in the measurements of this device in cases of keratoconus, also in the normals, and at the same time about the masking effect of the epithelium in case of keratoconus, and measuring the factors which may affect the or giving us a false Kmax, which may deceive us about the progression of this disease in such patients. I think you don't have the MS39 in your center? Or
no, I do.
You have it.
it.
Okay, perfect.
It's an amazing machine. So the MS39 on the epithelial map will give you the refractive power at the 3 millimeter optical zone and at the 6 for the epithelium. It's amazingly powerful.
Yeah.
And I think there's enough people using it now who are agreeing that the epithelial refractive power is actually quite accurate. So people are regarding that as being valid information. So it's remarkable. That's an incredible machine.
Yeah, very, very incredible. I hope to find it very soon here in our centers. We could see the donut, not the sweet donut, but the epithelial donut of the keratoconus.
Exactly.
Perfectly. The last question about this point is topography-guided ablation is much better with the PRK or the LASIK, because I will show you my point. Because the corneal irregularities or the cornea-related high-order aberration may be present in the surface of the cornea, also present in the anterior stroma than the posterior stroma. So if I went for LASIK, I will remove the anterior stroma in the flap and then ablate on the bed, which is away from a very important part of the cornea responsible for the high-order aberration. So it's much better to do the PRK with the topography-guided or the LASIK. What's your opinion?
It's a nice question. The way to think about that is to look at the epithelial map.
Yes.
And if the epithelial map is regular, you can do a LASIK. If the epithelial map is irregular, do a topo-guided trans-epi-PRK. So now you're using the epithelium masking to transfer. So when you look at a cornea like that, the two smoothest surfaces are the anterior surface and the endothelial layer. In between, it's very irregular. And if you do a trans-epi, all you're doing is you are transferring the anterior surface down into the stroma now. So now you have a much smoother stroma. And of course, when the epithelium grows back, it's going to have a better chance of making it even smoother. So the epithelium is always going to, if you look at the front surface of the cornea, whatever you are seeing is representative of the very best job that the epithelium could do. Yes. So if there's mild issues, you could have a perfect surface, but the epithelium might be irregular because it's hiding the surface. But the more irregular the stroma becomes, the epithelium can no longer compensate sufficiently, and then you see topographic issues. But the epithelium is always doing the most it can.
Yeah, okay, thank you. You have a common question, two questions. They are common from the last time, also in this time. They was sent from the audience on my Ziada Eye Academy page about the allowed depth or ablation depth in case of keratoconus when you go for PRK. The allowed depth and the allowed degrees of errors.
So, Hassam, it's, you know, all of this for the moment is mostly just people's opinion. I mean, I just don't go more than 50 microns because that's what people said initially. I have no scientific proof of that. David Lynn and Simon Holland go deeper and they don't have any problems. John Canalopoulos has many a time gone deeper as well. So I think it's left with how much you have behind. Are you going to cross-link that cornea? I don't know that there's a true answer. It's going to depend very much on our own experience and our own appetite for risk. I've always thought of a keratoconic patient as someone who already has enough trouble, and I don't want to add to the trouble. So I want to try and save tissue. I want to try and make the cornea as regular as possible, using as little as possible tissue. Yeah. And if there's still a refractive error afterwards, they've got contact lenses, they can wear glasses, they can have an ICL. So there are different ways of doing it. On the odd occasion, if I'm treating someone who's going to the army or the police or something, and they've come in to have a laser done, and we find out they've got keratoconus, and they've got a small error, then we'll do a topo-guided PRK to get them.
With any thickness, Arthur? With any thickness? The thinnest location should
be a small number. I'd always want to have left behind about 370, 380 microns of stroma.
370 microns after PRK.
Yeah, I wouldn't like to go less than that.
Including the epithelium? Including the epithelium?
No, stroma.
Yeah. After the epithelium, you will discalculate. You will remove the epithelial thickness on the side. Yeah, put it on the side.
Yeah.
Okay. The second point, do you believe in the refractive procedure extra, which is LASIK extra, PRK extra?
Wow. So in PRK extra, I guess we don't call it that, but we do that because those are the cases where you do a PRK for a keratoconic. You watch the cornea. Mostly it stays stable, but if it changes, we do a PRK, and I guess that could be called PRK extra, except it's 6 months later or 1 year later. But doing it at the same time, no. I've seen some publications. You know, I've done 50,000 LASIKs now, and in our first 10 years, we had 1 ectasia. And we left the cornea at 270. Everything looked fine to me, but this person got ectasia. And then since 2006, we've been having 300 microns as our bed, and we haven't had 1 case. So I just don't know. If you do good screening of the cornea, and you abide by 300 microns, and some people use the PTA as well, of Marconi Santiago.
Yeah.
If you're doing all those things, then I think your risk of running into trouble is very, very, very low. And so now if you think about it, you're doing all of these cross-linkings sort of unnecessarily. But people are saying they're getting good results. My experience is I haven't done it. It's not something I aim to do. I think if I'm treating someone who I'm concerned about, I certainly won't do LASIK. I'd much rather do PRK or an ICL.
Yeah, right. Yeah. You believe in to do the suitable patient or to leave it, or to leave him for another choice. If the patient is query or suspicious, I am not in need to do laser vision correction procedure and stabilize the cornea with the cross-linking. Either suitable and candidate or not.
Absolutely, I agree. 100%.
Yeah, okay, so it's not evidence-based practice.
I think some people who've published about it have got some evidence, but for me, I'm not convinced. I'm not convinced at all.
Yeah, and also most of the refractive surgeons are not like Mazen Sinjab, our dear friend. Yeah, is not recommending the LASIK extra. Also, Dr. Shafiq is not recommending, especially in the cross-linking expert meeting, the last one. Also, Farhad Hafizi is not. He has now a cross-linking state lamp, a cross-linking device.
Yes, very nice. What's it called? Imagine. Yeah, so look, there you go, 3 very good opinions from 3 very, very experienced and bright colleagues.
Okay.
I think in good company. I think it's best to do that.
It may be helpful in your way about the Epi-on to check this trauma, the riboflavin in this trauma, but it's very, very terrible for the doctor and the patient at the same time. I think it's very, very terrible for both to sit for a long time.
Oh, for this one. Yeah, I haven't tried that one. I think it'll be difficult. It's hard enough lying down.
Yes, it is.
It's a nice, I think a part of it though is also, was it not designed also for corneal infections? So those treatments are 2 or 3 minutes, I think.
Yeah. Okay.
I think that works very nicely, but for a cross-link, it might be long.
Okay, there. I watched the video for Farhad and Nikki Hafizi showing the celebration with having this device, which is a state lamp cross-linking device. Also, most of the audience are asking about Arthur Cumming is correcting up to which grade in myopia with PRK and LASIK.
Right. So yeah, this is very interesting. And I'm not suggesting you do this in Egypt because of the amount of sunshine you have. You have sunshine in 1 week that we have in the entire summer. So in Ireland, we have done PRK up to -12, up to -12.
-12.
I have a paper.
Really?
I have a paper that won an award at the AAO of 2010, I think, comparing LASIK between -8 and -12 to PRK between -8 and -12 with like a 5-6 year follow-up. There was almost no difference. So if you do a PRK in a cornea, that obviously the cornea needs to be healthy, but in the cornea that's fine, you're using mitomycin, and you live in a country like Ireland where UV is not a problem, it's not an issue. But of course, if you live in Egypt or Southern Europe, where you have a lot of sunshine, then I think most people are getting nervous, -4, -5, they're getting nervous about haze and that kind of thing.
I'm correcting up to -6.
Yeah, you would know much more about that than I know about it. In South Africa, we don't get quite as much sun as Egypt, I guess, but we get a lot of sun. But when I started refractive in 94, and I came to Ireland in 98. And I think when I came to Ireland, I'd done like 3,000 LASIK, but I'd done like 20 PRK. So PRK was not a big part of my early experience. I started doing PRK much more in Ireland because people were doing it here, and they didn't have problems with haze. We just don't have problems with haze over here.
Yeah, okay, the UV light exposure is the key in this issue, but what about the weakening of the cornea? You will leave behind residual stromal beta, which is less than the recommended.
No, never leave less than the recommended. Always will leave 300. So what's also different, in South Africa, a cornea of 550 would have been a thick cornea because the average cornea was like 500. In Ireland, the average cornea is 550, the average one. Thick corneas are 620, 630. So we see very thick corneas here.
Okay, let me ask here, because you are a wave-light consultant. What about the ablated depth for one diopter on the Alligator AX500?
At an optical zone of 6.5, which is our standard optical zone, it's 15.7.
15.7.
0.7.
On the optical zone 6?
Probably 13.
13, yeah, okay.
Probably.
So we have to calculate on the PTA. The PTA is considered in PRK like in LASIK?
Yeah, 40%. It would just be the, no. You have to add the flap in LASIK.
Yeah. So it's considered in the LASIK, just in LASIK, not in the PRK?
No, you can use the same, you can use it for PRK.
And the flap will be, the epithelial thickness will be instead of the flap in the equation?
Yeah.
Okay, thank you, Dr. Arthur Cumming, for this nice discussion about the customized ablation. Let's finalize or finish the discussion with the presbyopia. I know that your time is tight, but please give us your new aspects about the presbyopia correction, which is a preferable technique in correction of presbyopia in different ages and different patients.
So what we're currently doing for younger presbyopes is we look at the option of blended vision, a small amount of monovision. We've just finished a trial for a product called Allotex, which is corneal tissue. So you make a corneal flap like you do for LASIK, add this tiny piece of corneal tissue. It's 2.65 millimeters in diameter. It's 22 microns in height. You place it over the pupil. The results were spectacular. They were very, very, very good. But the trial is now finished recruitment, and it's just the follow-up. And again, COVID hasn't been fantastic for trying to follow up patients, but the patients are doing well, very, very well.
The Allotex?
Keratoconus, yeah, they're doing very nicely.
But I knew from you, the last meeting in our university conference, that the Allotex is a very thin lens, which is synthetic lens.
Cornea. It's cornea. It's human cornea.
Really?
From the eye bank.
Yeah. Okay. I thought it a lens, synthetic.
No,
lens.
the synthetic one was called Raindrop.
Yeah, Raindrop. Yes,
the human tissue, not porcine. Human tissue is Allotex.
Yeah.
It's incredible, very, very good. But it's not commercially available right now. And then what we're doing for IOLs, I've spoken to you before, I'm sure, about the Vivio device that measures your lifestyle. So there's a very nice thing. I must actually show it to you quickly. I'll show it to you quickly. It's phenomenal. It's a thing called the Lifestyle Match Index. Let me just try and find this thing for you quickly. Here it is. Have a look at this thing. I've got to share this with you.
Okay. So
you wear this device and it measures your own defocus curve. So can you see my pointer at the bottom here, the bottom right?
Yes.
Okay. So this shows you the distance vision. Then it shows you in blue, the intermediate, and then it shows you in green, the near. And these are just 6 examples. But if you had 600 examples, they would all look slightly different. So that's the patient's visual behavior. But also then shows you, here's the crazy thing it does nowadays. It then shows you, if I implant for this patient a monofocal, this particular patient, this patient's going to be free of glasses for 45% of the day, but this unshaded area, I'm going to need glasses. Now, Sam, your face is there. So what is this? This is what lens is this? A bifocal. So this
bifocal IOL, yes.
So this bifocal lens is adding 19% functionality, still missing here in the middle. The intermediate is missing. Now adding an epi-off, and now we're getting 37% increase, but we still don't get the reading vision. And now in this case, adding a trifocal, and we're getting basically everything. So what this device has is when you have your profile of the patient there, you go to this column here, which is generic monofocal. It always defaults over there. But then it does a search, just like you would do a Google engine search. If you're looking for a place to go on holiday and you say Egypt, and it comes up with this long list, then you look at the list and you still make your decision. But over here, what it does is it looks at your defocus curve, your personal defocus curve, and it matches it against every single lens that has a defocus curve. The list is now so long, I can't tell you. And it matches them and ranks them top to bottom of which one's going to suit best. And then just like with Google, you might look at the top one and say, okay, in this case, it's a lens I don't like. I don't like that haptic. I don't like that it's hydrophilic. Here's my first lens. It's got a nice haptic that I like, and it's hydrophobic. That's the lens I'm taking. So you can absolutely match. And you can tell a patient now, if you put this lens in, you're going to be free of glasses completely, or you might still need some help over here. It's also got the ability, when you look at this, to include mix and match. So you can have one eye, a trifocal, one eye, and epi-off. You can do monovision. You can take a lens like, I don't know if you know the new Vivity lens. It's an epi-off lens that gives you a very, very good depth of focus with 0 dysphotopsia, nothing. The dysphotopsia profile is exactly the same as a monofocal. And so based on this information, you can, in one eye, go for emmetropia, one eye you can go for minus 0.75, and you can see what kind of range you're covering and how it covers your patient's defocus curve. So it's absolutely phenomenal. And all the patient does is wear this thing on their glasses in their lifestyle, and that you get the measurements. So that's really helped. I can close this now. So that helps a whole lot in helping us decide what lens to put in. So satisfaction with multifocal IOLs is currently very high. I don't know what you have found in Egypt, but in Ireland, COVID has changed the way people think. Yeah. COVID has changed the way people think. They're coming in now and they're saying, I want to get out of glasses. I don't want glasses. I don't want reading glasses. I don't want nothing. These are masks. I don't want glasses. Yeah. So our rate of multifocal lenses now has never, ever been higher. More and more people are asking for them. And the other thing we're seeing with laser vision correction is patients are coming in and signing up. But before, you'd have a long discussion and try and convince. Nothing like that now. Now people just want it. Are you finding the same thing?
Yeah, the same thing here.
Oh,
Because
you're muted, Assam.
Yeah, no, I'm not muted.
Yeah, I think you're muted.
Me? No.
Yeah, I can't hear you.
Yeah, okay.
Oh,
Can
sorry,
you
my speaker's off. Sorry.
Okay, no problem. Actually, the problem here is when you show the subject of the trifocal or the multifocal IOL for the patient, when you show it in a clear way, most of patients were worried about the ups and downs falls after the surgery, because we have to counsel the patient properly and tell them about the time of adaptation. You may find some time glare if you have a larger pupil than the day different than the night, and so. But actually, let's agree that the trifocal and multifocal is expensive IL. It's not cheap one. So they are thinking a lot. Around 50% or even less, around 35% of patients who may think about the trifocal IL may change their minds after the counseling and the clarification of the points. And they may think another substitute procedure like the monofocal IL with a breast-basic after, or the monovision. So I would ask you about that. If I found that the patient is not candidate for, because of the large pupil, large mesopic pupil, and tell me, Arthur, about the mesopic pupil you can accept for that. 4-5 millimeter.
So we haven't seen huge problems with, the only problem we've seen with multifocals is in fact the pupil that's too small and too rigid. So for a multifocal to work, you have to have a pupil that is mobile. Otherwise you don't get the different zones coming in. But too big, not really a problem. And obviously with a good laser, if you do a 6.5 optical zone, then it's never a problem. I think one thing I always tell patients is if you choose blended vision or monovision, glasses can always correct glare at night. So that's an advantage there, where you can have glare at night with the multifocal. But most people adjust very well. You know, in all the years, we've never removed a multifocal, but in fairness, for all our refractive lens exchange patients, we always do a contact lens trial, and that's a lot of effort with a multifocal. And many say they don't like it, then we don't do a multifocal, obviously. But I think something we've learned is that when people understand what the problem is that you're solving, and they realize whatever you do is some kind of a compromise, they start realizing maybe it's a compromise that's worth taking. And something I must tell you, I want you to do an exercise for yourself. I'd love you to tell me next time I speak to you, is if you go into town today and you ask one of your colleagues, what will it cost for a multifocal IOL? And then you go down the road to go and see somebody who sells hearing aids, but someone who knows what they're doing, a specialist like you.
Yeah.
Ask them you want the best hearing aid. You're going to find the best hearing aid costs 5 times more than your multifocal. And people change that hearing aid every 5 to 6 years. They get a new one, a better one. That multifocal IOLs are crazy, crazy cheap. They are incredible value for money. They give you vision for the rest of your life. And so when I tell patients I want them to wear this device to find out what lens to put in, I don't say it's because the lens is expensive. I say the lens is very good value. The reason I want you to make the right decision about what lens to put in is because once you put it in, it's there for life. We're not going to change it.
Yeah, okay. But actually the patients in whom I have implanted the trifocal IL or the multifocal, all of them actually with very high social and educational levels. So they were accepting the possibility of the problems after. But actually, you mentioned the hearing aids. But the patient will think about the eye. If I put an IOL inside the eye and after surgery, he may find a problem with the IOL. I told him, smiley, I will remove it. then the patient is astonished. How to remove the IOL, to open my eye again and to remove the IOL. So from the start, I don't need it. Yeah, this is the point. The hearing aids is outside. There is no insult. There is no psychological insult for the patient to change.
Yeah.
The same idea about the LASIK and the glasses may be more costly or costlier than the glasses, but if the patient calculated the continuous cost of the glasses, especially if it's expensive one, he will pay more and more than the LASIK will take. Yeah, okay.
And there's another thing we've also started saying to patients, which has changed the way they choose IOLs, is we'd say to patients that they know what the risk is of falling and one of three things happening: either breaking your hip or breaking your knee or getting a head injury. So falling, breaking a hip, breaking a knee, or head injury increases by 11% when you're walking around with varifocals, with varifocal glasses, progressive glasses, 11%. So if you can tell a patient, if you put a multifocal IOL, you're out of glasses, you look younger, but you've just decreased your risk of falling by 11%. There's a lot to be said for it. So when people start understanding what all the benefits are, then they better understand the compromise they're making. And that's what I love about this Viveo device, because the conversation goes entirely about the patient's needs. We know exactly what's going on. They understand the problem. They know, if I put a monofocal in, I'm wearing glasses 65% of the day. Whoa, hang on a second. That's too much. So it's just better education. And the lenses will get better too. The lenses are already performing pretty well. You know, you live in a sunny place, it should be even less of a problem.
Yeah, actually, thank you, Arthur. What about the Presbyopia, the laser vision correction for the near? If you have a patient with 45 years old, I think you may think a lot about the IOL implantation. Yeah, we
would sometimes do blended vision. We do blended vision quite a lot. There's a new platform on the Wavelight called READ. It's a hyperprodate thing, but it's only for hyperprodate ablation, but it's only for hyperopes. I'm not a big fan of the Presby lasers, unless they're doing something like Presby-on, which is just working on spherical aberration. But the moment you really create a central steepness, I'm concerned about making the cornea less regular. If you think back about the question you had between wavefront and Topography-guided, I said, be careful about making the cornea less regular. If you make the cornea less regular with Allotex and you have a problem, well, then you lift the flap and take it out and you're back to where you were.
Yeah.
Because it's an additive technique. But when you're subtracting tissue to make it less regular, you've got to think about it carefully. I'm not a huge fan of that.
Okay, perfect. It's a good idea. The Allotex could be a substitutor for that, and it's easy to remove if there is a problem with it. But we are waiting for the Allotex to be popularized. Okay, thank you very much, Dr. Arthur Cumming, or the King Arthur. Yeah, I have a very good time with you in Chennai and also in the online meetings. I'm hoping to meet you again physically.
Yeah, absolutely, man. Yeah, absolutely.
And actually, Sphinx is asking about you, asking about the sunglasses that you have taken it from him. Don't forget this.
No, I haven't.
Thank you for your valuable knowledge and for your expertise. Thank you for sharing with us.
Thanks for the invite. Have a good weekend, everybody.
It's our honor and a pleasure, and thank you for the all audience, my colleagues and my professors those are with us up till now. And thank you, and my greetings to your family.
Thank you so much, Awesome. To you, to everybody.
And your precious granddaughter. Don't forget.
Thank you. Take care, Awesome. See you. Bye-bye.
Thank you very much. Bye-bye. Good night. Very good night. Bye-bye.